In this video, we're going to look at position time graphs. So let's say that you had a question like, find the position of the ball at t equal half a second. This is the easiest of all possible type problems, because all we have to do is draw a line straight up from the time, half a second, and then draw a line across and read the value from the graph. So the answer would be 6 meters was equal to the value of y at t equals 0.5 seconds. So if you have a position time graph, to read the actual position at any time is easy. You're just basically reading it directly off of the graph. In this video, we now have a position time graph and we're asked to find the displacement. So let's say that they wanted to find the delta y from t equal, say, 0.5 seconds to t equal 2 seconds. Well, this is basically two problems involving position. There's the location of the ball, or object if you would, at t equal 1 second, so that's y1. y1 is 6 meters, read right off the graph, coming straight across. We go over to 2 seconds, and we're right here. So we're looking over here to there, and that looks like something like 10.5 seconds. So y2 is 10.5 meters, I should say. So delta y would be 4.5 meters. 10.5 minus 6. Notice what that is. That is basically this distance right here is the displacement. That's delta y. In this video, we have a position time graph and we're asked to find the average velocity. And to do that, we know from the definition that we need to find the change in position over the change in time. So for our particular problem in vectors, we need to find the change in y over the change in time. Now, this is our location right here initially at t equal 5 seconds. Let's say that we're asked to do this from t equals 0.5 seconds to t equal 2 seconds. So that's where we need to find the average velocity in our problem. Then this would be one of the points. The other point at t equal 2 would be right here. And so what they're basically asking from our definition is for us to find the slope of that chord. Slope of chord. Now, we can find that by finding our displacement right there in green, delta y, and by finding our change in time right here, which is delta t. So delta t in our problem is 1.5 seconds. The change in y, this looks to be about 10.5. This looks to be about 6. So that looks to be about 4.5 meters. So our slope is 4.5 meters over 1.5 seconds is 3 meters per second, and that's the average. So to find the average velocity given a position time graph, plot the 2 points and find the slope of the chord between those 2 points. Okay, this is our last thing on position time graph, and this time we're asked to find the velocity at t equal 0.5 seconds. To find the instantaneous velocity, we need to draw a tangent line to the curve at the particular time that we're being asked. 0.5 seconds gives us this point right here, right there, and we need to try to draw as fine as we can a tangent line to that point. So a tangent line's kind of like that. And if we look at that line, we need to figure out what its slope is. So we need the slope of the tangent line. Alright, so to find that slope, let's go ahead and see if we can find a nice place. It looks like it crosses right about there. So it goes up about that high. And then it went over this far. So delta t would have been 0.5 seconds. That's right there. And I see that went up 2, 4, about 4.75 is a good estimate. So V looks to be about 4.75 meters divided by 0.5 seconds is about 9.5 meters per second at that point. Now, let's say that we've been given a different problem to work. We were asked to find, for instance, the velocity at this particular point here. Well, in that case, that tangent line is flat. So at this particular location, if that was the question, then the V would have equaled 0 meters per second. So at this location right here, at that particular time, which looks to be about 1.6 seconds, this particular object is in fact stationary. It has no velocity. Here it has a positive velocity. Over here the tangent line would be going down. It would have a negative velocity. So it had a positive velocity and then it slowed down, eventually came to rest, and then it picked up speed going the other direction. Anyway, that is how to find velocity. So if you can find velocity, average velocity, displacement, and position off position time graph, you can find anything that anybody asks. Now, notice if you can find the velocity at a bunch of different points, you can plot those velocities on a new graph, and you have a velocity time graph. And then you can go and use any information from that graph as well. And we'll cover that in another video.